is we are starting with classification of triangles and sum of angles in a triangle. So the first thing I want to ask you guys is, what is a triangle? Now ignore this picture. Let's do that. Oh my gosh, let's not do that. I forgot that I wrote all of that in. Okay, let's just leave this here. Or better yet, let's do this. Here we go. Now I want to ask you guys, what is a triangle? If I had to ask you guys what's a triangle, what would your response be? What would you tell me? A polygon with 3 equal sides. That's a super good definition. A polygon, if you don't know what a polygon is, it's a shape that has only straight sides. So it definitely is a polygon. So let's say polygon. So in other word, and a polygon, by the way, it's a 2D shape. So let's expand on polygon. A polygon is a 2D shape with, and let's combine it. We said straight sides, yes, but it has 3 straight sides. So 3 straight sides. 100%, a shape with 3 sides, 100%. You guys are all correct. And equal sides are for equilateral triangles, 100%. So it's a polygon. So in other words, a 2D shape with 3 straight sides. And because it has these 3 sides there, it also creates 3 interior angles. That's what we should know. Okay. So not something super important for you to know a definition, but just I thought it was important that you guys know the characteristics of a triangle. Right now, when we talk about a triangle, with, oh my gosh, why did nobody tell me I spelled polygon like that? Let's try fix that a little bit. Polygon. There you go. Hopefully that's a little bit better. Handwriting is not the greatest, but here we go. Interior angles, or loosely, if you think about a triangle, and let me insert a shape over here. If you think about a triangle, when I talk about interior angles, I just mean the angles that form inside my triangle. So I'm not worried about angles that form with other lines outside of my triangle for now. What I'm worried about is that the angles inside my triangle, there's 3 of those angles inside my triangle. So super important just to know the characteristics of a triangle. Now, triangles are super fun shapes in maths because there's a lot of ways that you can classify a triangle. And if we look at it, the first thing we can do is we can classify a triangle based on the length of their sides. So if I go back up and include my drawing here of a triangle, we can classify my triangle based on polygon. Yeah, my bad. Nobody even noticed or nobody said anything. Okay, so we can classify our triangles based on their sides. So when I talk about classify, I just mean there's different names for different types of triangles. And we can name a triangle based on the length of its sides. So we have a scalene triangle, and a scalene triangle is when we have a triangle and none of the sides are the same. If you have a look at the markings on my triangle, remember, or if you don't know, when we mark equal sides on shapes, we usually use lines. And the same lines represent, or let me not use lines, the same markings represent that the sides are the same length. So if I had these 2 markings here, because I see that they are the same markings, I know that these 2 lines are the same length. But in this case with my scalene triangle, if you look at the markings, none of the markings are the same, meaning none of the sides are the same. And here we have, it says, a triangle where all 3 sides are different lengths and all 3 interior angles are different sizes. So this is just a sort of an extra fact about it, that when all 3 angles, or rather when all three sides are different, all of your angles are also going to be different. But we base this triangle off of the fact that there are three different lengths. All of our sides are different lengths. That's a scalene triangle. Then we have an isosceles triangle. I love this word. It's very satisfying to me. I don't know why. But um, Lakeisha, no, it was just a mistake on my part. Okay, isosceles triangle we have over there, and you'll see I have two markings that are the same, which leads us to the fact that two sides are the same length. Okay, so two out of my three sides are the same length, and based on the characteristics of an isosceles triangle, something you should know is that the angles opposite the two sides of equal length are equal in size. A lot of words. What does it mean? The angles opposite the equal sides. So this angle is opposite that equal side, and this angle is opposite this equal side. So these two angles that I've now marked in pink, those angles are equal. If that doesn't make sense to you, don't stress. It's a whole rule that we're going to learn about, I think, on Thursday, possibly. No, next week, Tuesday. So if this is confusing for you now, don't stress. We're still going to go into detail about this. And then, oh yes, I did hear a hand earlier. Let me see. Is it Itandile? Yes.
Ma'am, can I please ask?
Mm-hmm.
Okay, I have okay. But then, ma'am, if our isosceles triangle only has two sides that are equal, ma'am,
Mm-hmm.
and the scarline has only zero sides that are equal,
Mm-hmm.
can perhaps a triangle have only one scarline and then it has an isosceles altogether?
No, because if the minute that there are two sides that are equal, it can't be a scalene, because with a scalene triangle, it means that none of my sides are equal. So I think what you're trying to ask is it right if you say, let's just say in this triangle over here, we have this line over here. If you're saying this line is a scalene line and this line, these lines are isosceles. Is that what you're saying?
Yes, ma'am.
Okay, so no, it doesn't work. The minute it can only be one. The minute there's two lines in the triangle that are equal, then it becomes an isosceles triangle. Because remember, we're not naming the lines, we are naming the triangle. So if there's no equal lines in the triangle, then the whole triangle is called a scalene triangle. When
Yes,
there
ma'am.
are two equal sides in the whole triangle, then the whole triangle is called an isosceles triangle. With me there?
Yes, ma'am.
Cool. Good question. And then we have our last triangle based on lengths over here. And this is where all of our sides are equal, which is basically the triangle I have up here. And this is what we call an equilateral triangle, basically what Uma has told us in the chat earlier. And this is where all three sides are equal in length. And a characteristic of this triangle is that when you have all three sides equal in length, all of your interior angles, what do we mean when we say interior angles? Remember, I just mean these angles that form inside my triangle. All of my interior angles equal to 60 degrees. Okay. So this is my classifying triangles based on side lengths. Are there any questions on this so far? If you do have a question, you can type it or raise your hand.
No, ma'am.
Thanks for that response, Liafo. Not hearing anything else. Moving on. Then, the next thing that we can do is we can classify our triangles based on their angles. So, when we have a triangle and we don't know the lengths of the sides, maybe we can classify these triangles based on their angles. So we have our first one over here, which is called an acute angled triangle. And let's read what it is. This is where all interior angles are less than 90 degrees. In other words, they are all acute angles. And you can tell when something is an acute angle because remember, this is a 90-degree angle. If this arm, think of this as a clock hand. Right now, this is a clock hand. If this clock hand has to move any more towards the right, it's going to be an acute angle. It's going to create an acute angle. The minute it moves to the left of this 90-degree space, that's when it becomes an obtuse angle. And so you can tell, you can see here, this, it didn't go past my 90 degrees. This, if I had to do a 90-degree angle here, it didn't go past 90 degrees. And if I had to make a 90-degree here, you can see that didn't go past either. It's not wide. It's instead making a little angle. So we see all of my angles in this triangle are acute angled triangles. If you don't know how to tell what's an acute angle, always draw a 90-degree angle and you think to yourself, is this arm opening or is it closing? If your arm is closing, then that means it's acute. If it's opening up, then that means it's an obtuse angle. Umar has always got extra information for us in the chat. That's correct, Umar. Okay. So we have this acute angle triangle, which then leads us to our next one, which is an obtuse angled triangle. And this is where there is one angle that is an obtuse angle. Now, if you think of the nature of triangles, and you'll see now as we go on what I mean, that we can't have all of our angles, obtuse angles, in a triangle. So with acute angle triangles, yes, all of them are less than 90. But with an obtuse angle triangle, there must only be, or there only needs to be one obtuse angle for it to be called an obtuse angled triangle. And if you look here, I see already where my obtuse angle is. If I were to draw a 90-degree thingy over there, I can see my arm has opened up, meaning this angle at the bottom is an obtuse angle. And then lastly, we have our right angled triangle. Okay, so this is where we have one interior angle, which is exactly 90 degrees. So if you go and you draw your 90-degree thingy-mabobby, you'll see your arm is exactly on it. It hasn't opened and it hasn't closed. It's exactly 90 degrees. And this is how we can classify triangles based on their angles. Any questions on these last three? Itandile, can you explain the acute angled triangle? Sure. When we have acute angles, remember when you learned about angles in grade 7, you would have learned about a right angle. And let me actually try and draw this straight. There we go. You would have learned about a right angle. A right angle is 90 degrees. Then you would have also learned about anything less than 90 degrees. So anything less than 90 degrees is what we call an acute angle. And then anything more than 90 degrees, over there, anything more than 90 degrees is called an obtuse angle. So when I say more than 90 degrees, that's the greater than sign, more than 90 degrees. But remember, it has to be less than 180 degrees. Because when we have 180 degrees, this is where we have our straight angle. And I've missed an A over there, but we're just going to ignore it. And then when we have our arm, and our arm goes like this, Look at where we started. We started here, and our arm has gone all the way around. This is a reflex angle. Okay? Reflex. That is bigger than 180, but less than 360 degrees. Okay? And then when you get it exactly like this, and it's a full circle, that is then 360 degrees, and that's a revolution. Okay, so when we talk about an acute angle triangle, all of our angles in that triangle is going to be less than 90 degrees. Um, Itandile, I'm not sure where you were stuck on, if it was the angles that were confusing you, but I've just explained all of the angles now. And so when you have an acute angle triangle, you must check that all of your angles are less than 90 degrees. And so that's why I was drawing these little, so you can pick any side, draw a straight line, and then draw where the 90-degree would be. So make a corner, make a straight corner, and you're going to see, is my arm opening or is it closing? And you'll see in all of these, the actual lines of the triangle are inside this 90-degree angle, meaning all of these angles are less than 90, which means they are acute. Bri, I see your hand. Yes?
Hi ma'am, I'm
Okay.
everyone. So, I'd like to ask for the like obtuse angle triangle.
Mm-hmm.
Like the definition is one interior angle is an obtuse angle.
Mm-hmm.
Why is it like what happened to the rest? The other two angles? Will they also be an obtuse angle?
No. So I don't want to confuse you just yet, but maybe you know that the angles in a triangle are supposed to add up to 180 degrees. Did you know that, Bri?
Yes, okay.
Yes. So if we have an obtuse angle, think about the fact that it means that this is more than 90 degrees, right?
Yes,
If this is more than 90 degrees, it means that these two can't be more than 90. They have to be less than 90, because if I add 90 plus 90, that's what gives me 180. Do you see that?
yes, ma'am.
So if this one is more than 90, it means that these two combined need to be less than 90. Does that make sense?
Oh, yes, it does. Thank you,
So, and
ma'am.
that's why I said, because of the nature of a triangle, because of this rule that all of my angles in a triangle must add up to 180 degrees, there can only be one obtuse angle in my triangle. Make sense?
Yes, it does.
Cool. Happy days. I didn't see any other hands. You can most definitely take a screenshot. Let me zoom out for you. Yeah, oh, there you go. And anybody else who wants to take a screenshot, here's all of it on screen. And then I'm gonna move on if there are no further questions. If you have a question, you're more than welcome to ask whenever you need. And if you are confused about what I was talking about, 180 degrees, what, here is an explanation. So it says, let's have a look at our first geometric reason or geometric rule when using properties of triangles. So what we covered in our previous weeks was we just covered normal geometry rules. So we spoke about angles around a point. We spoke about fun angles. Those are angles that only work when there are parallel lines. We spoke about vertically opposite angles. Those are all geometry rules that we know. Now, what I'm telling you is that there are more geometry rules that apply only when we are dealing with the 2D shape called a triangle. Okay? And so there are actually quite a few rules. There are actually quite a few rules that deal with triangles. But for now, the first rule we're going to learn is that all of the angles inside of a triangle, when you add all of them up, in other words, when you sum the angles inside a triangle, those interior angles, when you sum those angles, they are always going to give you 180 degrees. Now, Again, if you think about what a rule is just something that always works, okay? Just like the rule of what can we say? The rule of the road, right? If you think about the rules of the road, those are just something that we have to follow because it works. Every time you go to a robot, the same rules apply. So every time you see a triangle, this rule is going to apply, whether it's an isosceles triangle, whether it's a scalene triangle, whether it's an equilateral triangle, any triangle you see when you add up all of the angles inside a triangle, it is going to give you 180 degrees. And when we are using this rule in geometry to find unknown angles, if we use this rule, we have to always give a reason. And our reason is because of the rule of sum of angles in a triangle. And so I see you guys working out the first one in the chat. I love to see it. And so what do I mean? What do I mean when we use this to solve unknown angles? Well, let's look at this first example I have here. And the first example is a triangle, and there's an unknown over here. There's a variable, which is x. I don't know what x is, but I know my other two angles are 70 and 40. So if I ask you to solve for x, if they say determine the value of x, what are you going to do? Well, you're going to say this is a triangle. And inside a triangle, I have two angles that I know of, and there's only one unknown. The minute there's only one unknown angle in a triangle, this rule can help you because it means that the first angle plus the second angle plus my third angle is going to equal to 180 degrees. Why am I saying that? Well, I'm saying that these three are going to equal to 180 because of the sum of angles in a triangle. Okay. Up until this point, can you react for me? Use your reactions. Let me know, do you understand how I've made my statement and how I have given my reason? I heard some hands. The first one I saw is Kia. Yes, Kia.
Good evening, ma'am. Good evening, everyone. Ma'am, can I please ask them something?
Mhm.
I see we always start with the numbers. Is it wrong to start with the X?
It's not wrong. I only do it because it's just easier for me when I move it across. It, like, in my mind, X stays in the exact same place. You know what I mean? But it's not wrong at all to start with X. All that will happen is that your numbers will move over to the other side, but your X will still stay on the same side. Does that make sense?
Yes, ma'am. Thank you.
So it's not wrong at all. This is just the way I've done it. You could have said 40 plus 70 plus x. You could have said x plus 40 plus 70. You could have said 70 plus x plus 40. Any combination of those is okay, as long as you've added all of them together and told me that it equals to 180. I don't see any other hands. Let me just double check that. Nope, no other hands. So happy to see that we're all happy. And then what we do is we can either move these over individually. Why do I want to move it over? Remember, what we've set up for ourselves here is an equation. When we are doing an equation, what's the golden rule? The golden rule is we want to get our variable, which is our unknown. We want to get our unknown by itself. We want to get it on a side by itself. And so what we want to do is we want to remove everything else that's on the side where x is. And so to do that, I need to remove this 70 and this 40. So let's first add it. Let's say 70 plus 40 is going to be 110 degrees plus x, which is going to equal 180. And now I need to remove this 110 degrees. And when I remove it, this is actually 110 being added to x. So in order to remove this addition of 110, I could go and minus 110. But because I minus 110 on this side, I must minus 110 on the other side. The addition of 110 and the subtraction of 110 cancel out, And what I'm left with is x is equals to 180 degrees minus 110 degrees. Now, the simpler method to do this, the shortcut that we use, is we say we transpose. So when we take something over to the other side, because remember, we want to get x by itself. So I say I see a loose term. When I have a loose term, remember a term is separated by pluses and minuses. So when I have a loose term, I can say that I transpose it. And when you transpose it, you just take it to the other side and change the sign. You'll see that's basically exactly what I've done over here. So I've showed you the long method, I've showed you the shortcut. If you've forgotten the rules of equations, go back and watch our series on solving equations. Okay, moving on, 180 minus 110 gives us 70 degrees. And our final answer, and thank you to everybody who had it in the chat. You guys are great. Okay, so that's this one. I think we'll do these next two before we move into our brain break. Let's put up 3. We have 3 questions up on the board. Anybody want to help me answer? Itandile, I think your hand was up first. Let's go.
So, ma'am,
Mhm.
we're going to say 46 plus x plus 90. Why? Because the sum of angles in a triangle add up to 180. Then we are going to solve.
So what's my statement over here? 46 plus x plus 90.
Yes, ma'am.
I'm not done. I don't have an equation yet.
Is equals to 180.
Is equals to 180. When I add up my 3 angles, they must equal 180 degrees. Cool. How did you know this one was 90? Where did you get 90 from?
Because, ma'am, I knew it was because the reason it's 90 because it's a right angled triangle and the 2 parallel lines make 90 degrees.
There are no parallel lines. Remember, parallel lines are lines that never touch. So no parallel lines in here, but it was a little bit of a trick question. All you needed to tell me is that this little box here is the symbol for a 90-degree angle or a right angle. So that's how we knew that this was 90, because this is a right angle and we know right angles are 90 degrees. Cool. So now that we have this, what do we do next?
So, ma'am, I like to plus all my 90 plus my 46, which is 130. So it's going to be 139. Sorry.
136.
100 is equals to 180. X is equals to 180 minus 130. 136, which x
So
equals to
Itandile has said she wants to get x by itself. I can remove this 136. Let's transpose. When I transpose, I take my 136 over to the other side and change the sign. Okay, cool. And final answer?
it's 44, ma'am.
44. Correct. Thank you, Itandile.
My pleasure, ma'am. Can I please take a short break?
100% you can. You've earned it. In the meantime, Bree,
Hi again.
hi.
For number 3, we're gonna say 20 degrees plus x plus 130 equals to 180. My reason for this is sum of angles in a triangle.
I'm so proud of all of you guys for always giving me your reasons before you solve the equation. Well done, yes.
Then we're gonna like transpose, but first we're gonna write x down
So these are the ones we want to transpose. X, yes.
equals to 180.
Mm-hmm.
Um, 30 plus 20 is 150. Oh,
Okay.
yeah.
So let's just do all that in one step. Minus 150. Mm-hmm.
And then x equals to 30 degrees.
Equals to 30. And Bree, now that you're here, do you see that this is an obtuse angled triangle? There's one obtuse angle, and then my other two angles are acute angles.
Yes, I do see that, ma'am.
Great. Thank you, Bree, for that. Is there a third hand? Let's have a look. I don't see a third hand, so I think maybe I'll take this one by myself. Let's do the last one before we move in. You guys can see very repetitive. I have a triangle. I know two angles inside my triangle. I'm looking for a third angle. I know of an equation that I can use that will only leave me with one unknown. And that is that if I add 94 degrees plus 23 degrees plus, I'll call it x, plus x, I know that that should give me 180 degrees. Do you see in my equation, there's only one variable. This is how I know it's going to work. When you use a rule and you see that there's actually more than one unknown, then it's not going to work. So this is what I mean. If you were here for our previous week's sessions, I said that you always want to use the tool that's going to work for you. So it's okay to pick up a tool, see that it's not going to work, and then put it back down. That is okay. It's okay to write the wrong statement and then say, oh, wait, this is actually not going to work. Cross it out, try again, try another rule that's going to work for you. And that's also why I liked Uma's joke so much, because it's related to tools. And that's exactly what I was talking about with geometry, is that all of our rules are tools that we have in our toolbox to use. And so you just have to pick up all of your rules, pick up all of your tools until you get the one that's going to work for the job you need to get done. So over here, I see this is going to work for me. My reason is sum of angles in a triangle. And let's solve. So I'm not going to add. I just want to show you guys a different method to transpose. I can transpose each of those numbers individually. So it'll be minus 94 degrees, minus 23 degrees. I do my math over here. Oh, somebody tell me what this is. 63. I'm trusting. The last two answers I see, which is 63. And there we go. Okay, cool. So this is it. I hope I did see some answers in the chat. If you got it wrong, go ahead and check where you went wrong. Make sure you understand where you went wrong. If you don't understand where you went wrong, raise your hand. Let me know what you did. Tell me what's confusing you so that we can talk about it. Too easy, Liako. Love to hear it. I see a hand. Let's see. We have not Avril, Demi.
Hello, ma'am. Can you hear me?
I 100% can.
So my mistake was
Mm-hmm.
I wrote in math book 36 plus 94 instead of 94 plus 23. I wrote
Oh,
the incorrect.
I see. I wonder where you got your 36 from.
Yeah, that is my mistake. Sorry, ma'am.
Okay, no, that's not a problem. As long as you know where you went wrong, then that's great. Then you know you'll never make that mistake again, or at least we'll hope.
Thank you, ma'am.
Cool. So let us go into our favorite game. We have one must go. Demi. How it works is I put up 4 pictures and then we argue. Well, we don't argue, we debate. In the chat, I take 2 hands per like Bobby. Shady, your word has made me self-conscious. I take two hands per thingamabobby, and you can tell me what you pick that to leave. It's gonna leave forever. It's not gonna exist. Um, so personally, I don't know what my answer to this is. I think Suicide Squad, right? Like I grew up on X-Men. Avengers is pretty cool. Justice League, I also sort of grew up on like SABC2 cartoons of Justice League. So Suicide Squad was never relevant until recently. So Suicide Squad must go. That's my take. Let's see our hands. We have Liaho, whose hand is up first. Yes, Liaho.
Ma'am, I get rid of X-Men. And I can also get rid of Suicide Squad.
Why X-Men?
Because, ma'am, I don't really watch Suicide Squad, ma'am. I never watched it, even X-Men as well. Well, I know X-Men, but yeah. But, ma'am, Avengers is too good and Justice League. But I'm not really a DC fan.
I see. Liaho,
Yeah,
I'm surprised as a Fortnite player that you've not watched X-Men.
I know, right, ma'am? But, ma'am, yeah, ma'am, but I don't really like X-Men, but yeah. I just don't like it. I'm sorry, ma'am.
Okay.
Sorry, ma'am.
No, I get it. I get it. I think it was like before your time, so it's fine.
Yeah, it was.
Unati, let's hear your take on it.
Ma'am, X-Men must go. And Suicide Squad is definitely staying because why would you get rid of the Joker and Harley Quinn? They're so iconic.
That's true, but the Suicide Squad, I mean, technically, the Joker and Harley Quinn would still exist in the Justice League world, right? As Batman's rivals.
I guess, but like, it just
Hmm,
makes no sense to get rid of them. Suicide Squad is elite.
okay. I see your point. I see your point, but I still stand by my answer. Thanks for answering, Unati. Let's move on. So Squad ain't do nothing to you. Let it stay. But that's what I mean. It didn't do anything for me. It was not my childhood cartoons. It wasn't anything interesting. It did nothing. So it must go. Moving on, we have more superhero groups, I guess. Now we're moving on to cartoons. We have Powerpuff Girls, Teen Titans, The Incredibles, and the group inside the Scooby Doo thingy is called Mystery Inc. I don't know. Truly, I love the Powerpuff Girls. I used to watch Teen Titans all the time on Disney XD. I think that's what it was. I think it was on Disney XD.
No, ma'am, Cartoon Network.
Oh my gosh, you're right. No,
Yes,
wait.
ma'am.
Yahoo, no. Oh, no, you're right. What
Yes,
was on Disney XD? There was a superhero thing that was on Disney XD. I can't remember what it was. Anyways, yeah, Teen Titans, love that. The Incredibles, come on, man. I mean, yeah, I don't know. Maybe some of you didn't watch it, but like, my childhood, The Incredibles were a thing. And Scooby Doo, like, oof, I don't know. But if I had to pick, like, had to, I think I might get rid of The Incredibles. No, I don't. I don't know. I don't know. I don't know. Let's hear what you guys have to say. Ethan delay, yes.
Ma'am,
Mm-hmm.
I have beef with you. I have beef with you.
You
I'm gonna
always
eat my
do.
beef. I'm gonna eat my beef. Ma'am, how can you get rid of the Incredibles? In my defense, I hate the Powerpuff Girls. I hate those average little sized whatever superpowered girls who act like they're undercover during the day. Ma'am, no ways. I'll take away two things by the way. Machine Inc. Didn't like it as a child, still don't like it even now. I don't know what's wrong with me, but then I don't like it. I don't even know what it is, but then I don't like it.
Oh my
I never
word.
watched it as a kid.
No.
I promise you, man. And then I also have beef with the Teen Titans. I have beef with the Teen Titans. Y'all are teenagers. What are you doing? What are y'all doing? Where did y'all get the powers? Hi, remember? People, I have beef. I think I'm not a super. I'm not a supernatural person who don't believe in mystery stuff and the supernatural things. But
I get
you
it.
mind get the Incredibles. Okay, I have beef with that also, but then it's like a little. It's because man, the Incredibles were like a super famous family. Like, come on, no ways. You're
I see
undercover
people in
as
the
a
chat. A
Santa.
lot of people are saying Mystery Inc.
Yes, ma'am.
And The Incredibles. I see. Thank you.
However,
Lakeisha is my friend. Lakeisha doesn't have beef with me. Lakeisha, I agree with you. You had a bad childhood if you didn't like Powerpuff Girls and Teen Titans. Itandile, that is the tea. I'm moving on to the next ad. Nkuli, yes.
Ma'am, I'm really mad at you right now.
Why?
You chose one of the all-time greatest cartoons that ever existed and just shoved it in the playlist. I'm also mad at Itandile because how could she say that you don't know Mystery Inc. You don't know Scooby Doo. You
it's
don't like
because
Teen Titans.
Gully, look, love. The only reason I don't like Mystery Inc. is because I didn't watch it as a kid. I like the Scooby Doo supernatural stuff like that. Like that is like no ways, no ways, no ways, and no ways.
So, Nkuli, which one would you get rid of?
Oh, that's a hard one. I'm gonna have to say Teen Titans Go because no, I don't like that show.
Oh no.
I just didn't like it as a kid.
Man,
I just didn't like it.
man, you know
But the
why?
rest is nice.
Ma'am, you know why I think I agree with Goody with the Teen
Mm-hmm.
Titans Go kind of part is because, man, like, y'all are teenagers. What are y'all doing with powers? Y'all doing come on, come
No,
on,
Basically,
no,
no.
but
the
Raven wasn't a
Incredibles.
galaxy princess thingy, and same thing with Starfire. She was also a galaxy
Yeah.
princess,
The Incredibles have three
Destiny
little
Queen.
kids that have powers. So, what's your
And
point,
ma'am,
Itandile?
ma'am, what I know is that all these shows, they're not incredible. Like,
Ugh,
like Cartoon Network, Disney needs to do something better. It needs to come with something better because no way it's like,
okay,
mm-mm.
guys. Okay. Let's go to the next one because we do still have one more. Now, you guys, firstly, let's not judge. Let's not judge my one must goes because I'm running out of ideas for these things. I'm running out. So here we have musical instruments now. I don't want you to think of like songs. I want you to think of like solos. You know, like when you have like solo artists and you hear them playing the piano and it's just like beautiful. It's like wow. And you hear violinists doing their solo and it's like wow. I want you to think of maybe like the orchestra. Think of that. Don't think of like your everyday songs because obviously it's going to be different. Think of solos. And whoever said drums in the chat, I'm with you. The drums sound disgusting as a solo. Like, no offense to anybody who plays the drums. But it's like, it's not that deep, you know? Like, we can do that with a box, you know? We used to play drums with boxes when I was small. Like, I'm sure everybody did that. So the drums, nothing special to me. So that's what I'm getting rid of. Let's hear what our last two hands have to say. I'm gonna give Kia a chance. Kia has not gone. Yes, Kia.
Ma'am, for me, I think piano must go. For me, it's too complicated.
I get it, but don't you love hearing other people play the piano?
No, ma'am.
Okay, fair enough. Then yeah, for sure. Then I agree with you. If you don't like it and you don't like hearing other people, piano must go for sure. Okay, Kia, thanks for answering. Then we have our last hand that I'm gonna take, which is gonna be Umar. Yes, Umar.
So basically, right, I'm gonna get rid of violin because it's like it's very hard for you to learn how to play it. It's like physically impossible. No one can do it.
What do you mean? There's so many violinists, Umar.
Man, those people are mentally insane.
I love hearing people play the violin. It's like so soothing. It's so calming. There's nothing like it. It gives me goosebumps every time. I would never get rid of the violin, Uma. But I see your point in that if you were to play it, if you were to play one of these violin, let's go because it's like that's too much. It's doing too much now. Okay. Moving on. back to maths, guys. To those of you who have your hands raised, I'm sorry. I'm sorry, but you all had a turn. So, moving on. I'd want to do this one that we skipped. I want to do this one that we skipped because it looks interesting. It looks interesting. I heard a hand. Do we have questions? Whose hand is it? Let's check. Itandile, is your hand up from the brain break, or you want to ask a question or answer?
Ma'am, I'm answering.
Okay. Umar, do you have a question, or did you want to answer?
Ma'am, I wanted to answer so badly, ma'am.
I'll
Omar,
keep a
you can
hard one
take
for
it.
you.
You can take it, Omar. It's fine.
No, but
It's
I'm sure
quite-
there's another hard one. I'll just keep another hard one for Umar to do at the end. Yeah. You can do the last one, Umar. That's hard.
Ma'am,
So-
don't forget about me, ma'am.
I won't. Yes, Itandile, tell me what I'm doing here.
Ma'am,
Mhm.
you can say x plus 35 plus x plus 10 plus x minus 15 is equals to 180. The sum of triangles add up to 180.
Not sum of triangles, sum of
Sum of
angles.
angles in a triangle add up to
100%.
180. So, ma'am,
Hold on,
I'm-
Itandile. Now, everybody, how did we get this equation? Well, what we said is that what I know still applies. I know that if I add all of my angles together, they are going to give me 180 degrees. And although I don't know the exact measurement of any of the angles in a triangle, I see that they all involve the same one variable. So because I see that I sort of have somewhat of an angle for each angle in this triangle, and that all of them involve the same variable, I know I can create this equation from it, which is really just adding all of the angles. And so that's what Itandile has done. This x plus 35, she said, this is angle 1. We plussing angle 2, which is going to be our x plus 10. And then we plussed again our third angle, which is going to be our x minus 15. So what we did is we still plussed 3 angles together. It's just that in this case, our angles were a little bit more complicated than just a straightforward number. So now that we've got this equation, we can actually work this out to work for us. So let's hear how Itandile tells us we're going to do this.
So, ma'am.
Mhm.
Okay, ma'am. So, what I did, I plussed all my constants and I also minus, and which I said, which is x plus x plus x plus.
Mm-hmm. So we have, let's just group it together first. We have x plus x plus x. Let's put all our terms together, all our like terms together. And then all of the other ones is this plus 35, plus 10, and minus 15. Okay?
Yes,
So we have
Then I-
35, 10, minus 15. Now what?
So, ma'am, so I just put down all of my variables as they are, and then, ma'am, I said to myself, if 35 plus 10, which gave me 45, minus 15, which gave me 30, so I said plus 30 is equals to 180 degrees. And then, ma'am, I plot all of my 3x's, ma'am. When I said 3x plus x, which gave me 3x plus 30 is equals to 180. Then, ma'am, I rightfully put down 3x as it is, and I said is equals to 180. Then I transposed and I made my 30 into a negative, because when we transpose, a positive becomes a negative. And then, ma'am, I said 3x is equals to 150. Then I both sides by 3
Mm-hmm.
because my variable has 3, and for me to get rid of 3, I need to divide by 3 both sides, which gave me x is equals to 50.
100%. Thank you very much for that answer, Itandile.
Thank you. It's
Now, if you're confused about why we divided by 3, this is 3x. We ended up with 3x over here. 3x really means 3 times x. Now, 3 over here is not a loose term, so I can't just transpose it and take it to the other side and make it minus. Remember, a loose term must be separated by plus and minus. This 3 is not a loose term. So, to get rid of this multiplication, what I do is I use the inverse operation, which is division. I divide it by 3, and when I did that, my multiplication and my division by 3 canceled out. And then what I did was divided the other side by 3 because we're dealing with an equation, and that is how we got to x is equals to 50. If you have a question, you are more than welcome to raise your hand. But I am going to our last one for the day that Uma is going to do for us. Uma, you can decide which one you want to do from these 3. I think the last one.
Ma'am, I'll do all of them, ma'am.
We have 1 minute, Uma. Pick one.
I'll do the hardest one, whichever one you think is the hardest, ma'am.
I do think it's this last one. So let's go.
So what I'm gonna say is 96 plus 2x plus x plus 12 is equals to 180. Now using a sum of angles in a triangle.
Good job. Uma disappeared.
No, ma'am. I was waiting for you to write down everything, ma'am.
Sorry. Yes. Go.
So what I'm gonna say is, so I'm gonna write 3x is equals to 96 plus 12, which is equals to 180.
Okay, so we have like terms. We added 2x plus x gave us 3x. 96 plus 12 gives us
108.
108. Good job.
And now what I'm gonna say is 180 minus 108 is 72. 3x is equals to 72.
Good job. So we transposed our 108. So that became 180 minus 108. Good job.
Now what I'm gonna do is divide by 3 on each side because you want the x by itself, right? So when you divide it, you're gonna get 24, ma'am.
I'm trusting your math. I think that's correct. Yes, it is. And so we have our answer. X is equals 220.
See, ma'am, you don't need a calculator for everything, ma'am.
100%. I agree with you. Uma, you've done that very, very well. Thank you for finishing off our lesson for us. I see a question. Yes,
ma'am,
Uma?
for the first time, I never rush through my answers, ma'am.
I know, you explained it beautifully. Well, I'm sure I can fit it all on this one screen. There you go.
Thank you, ma'am. Bye,
And
ma'am.
bye, Itandile. And then we have Uma's hand up next. Uma, do you still have something?
No, ma'am. I wanted to speak about the theorem of Pythagoras because, like, I'm slightly confused on it. If they give us the hypotenuse, right, and they want us to calculate one of the sides, how do you calculate it, ma'am?
So it's just an equation. So they've given you the hypotenuse. So this, let's just call it 3, 4, 5. Let's call this 5. They've given you this is 3. They want you to calculate the other side. What you know is you still know. I'm not sure how you learned it, but I learned it as x. I learned Pythagoras as x squared plus y squared equals r squared. So r being our hypotenuse. So all we do is we substitute. I know this 5 needs to be substituted in here. And I know this side can be substituted in x. And then it leaves me with y as my unknown. So what I'm going to do is I'm going to say 3 squared plus y squared is equals to 5 squared. And then it's an equation, Uma, that you're going to manipulate. Remember, we want to get y by itself. So we're going to move 3 squared over to the other side. And we're going to get y squared is equals to 5 squared minus 3 squared. Now, I can't just go and say 5 squared minus 3 squared is 2 squared. No, it doesn't work like that. You have to say 5 squared is 25 minus 3 squared is what, Uma?
9.
9. 25 minus 9 is 16. But we still have y squared on the side.
You
What's the
square root
opposite
it,
of a
square
square?
root it, and y is equals to 4.
100%. Happy, Uma?
Yes, ma'am.
Cool. You're ahead of us. We're going to cover Pythagoras in 2 weeks' time. So if anybody's still here and is confused about what I'm doing, don't stress if you don't know Pythagoras as yet. Bye, Uma. Liacho, yes?
So, ma'am, what are we gonna learn in term 4?
Yo, what a hard question. I can't recall. I do remember we're going to do area, perimeter, volume, surface area. We're going to do graphs. So we're going to learn how to do graphs. I know we've kind of touched on it already, but it's
Yeah.
separate topics in your grade 8 syllabus. So we're going to cover that again. That's all I can remember off the top of my head.
Okay, ma'am. Thank you, ma'am. Bye. Good night. Enjoy.
Pleasure. Bye and good night.
Good night.
Yes, Demi.
Hello, ma'am.
Hi.
Ma'am, I would just like to know, when does the quiz happen? Like,
Okay, so how it works is every Thursday I release a quiz. So what will happen is at the end of the class on Thursday, I send a link in the chat. But Demi, are you joined in on our Google Classroom?
I'm not sure, ma'am. I should ask my mommy.
Okay, I will send you a link that you can maybe copy and paste. And then if you're not part of the Google Classroom, this is the link that you're going to use to join the class.
Okay, ma'am.
And then once you're in the class, even if you don't take my link that I send in the chat, you can still get the quiz by accessing it in our Google Classroom itself. I don't know if that makes sense.
Okay, ma'am.
So I'm just putting the link now in the chat. So copy this link just in case. If you ask your mom if you're joined in our Google Classroom, she'll either tell you yes or no. If you're not, this is the link you're going to click and it'll join you into our Google Classroom. And what that basically does is it shows you all of the stuff that I post in class. And so I post the quizzes there every Thursday. I also post the link to the quiz in the chat in our actual virtual classroom. So if you don't get the link from the chat, then you can get it from the Google Classroom itself.
Okay, ma'am.
So you're going to do the quiz. You have up until Sunday to do the quiz if you want to be featured on the quiz podium or as our class comedian, as you would have seen at the beginning of class today. There's also a question in the quiz to tell me a joke. So yeah, that's how our quiz works. But if you don't do it by Sunday, that's okay. You can do the quiz anytime you like. You just won't be featured, obviously, in the podium or on the welcome board.
Okay, ma'am. And ma'am, I have one more question.
Ask away.
My teacher told we were busy with in class. Just hold on. Today we were busy with like the quadrilateral shapes. We know we're going to touch on that because some of the work my teacher so basically I remember, as far as I can think of, we only did 2 topics this year. It's the linear binomial equations and the geometry. But okay, triangles, the work that we've done today, I can understand it. Some of the work I can understand, but like the angles with the parallel, like the mixed, it doesn't make sense. So when are we going to go do that?
Okay. So, Demi, you have just missed it, unfortunately. But you are more than welcome to go ahead and look at the lessons on YouTube. You can literally just Google Maths Live, and then you'll see our YouTube will pop up, and you're going to go to the grade 8 class, and you're going to look at just the previous set of lessons, the last 6 lessons I did.